Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Are you enjoying this course? No?
Enjoying,
Yes,
sir.
day
Yes,
by
sir.
day, getting tougher.
That is the nature. You guys are more tougher than this subject. And I do believe from my heart that you guys are much more capable than what the level I am teaching you. Only thing, you don't want to come out from your this comfortable region. But right now I was watching one seminar given by Professor Anindya Chatterjee of IIT Kanpur. It's a AICT seminar. I'll send you the link. You all must see that because you must know where you are, where the mechanical engineering is. Many people wanted to go into software. Obviously, we wish them good. We wish them good luck. But mechanical engineering will be there because without mechanics, this world will not exist. And when you are learning, when you are in this training of mechanical engineering, please concentrate on your study. It will help you, believe me. So what we are going to discuss today, ask me some questions from the last class.
Yes, sir. Sir, I have a question.
Yep. Just give me 1 minute to share the screen. Okay. Yes, please go ahead.
Sir, can you show the diagram that was drawn yesterday?
Which diagram? This one?
OAB.
This one? Yes.
Yes, sir.
Hmm.
So let's say that this AB vector is rotating around, is revolving around some center.
Hmm.
Uh, so then we will need to add some omega component to R naught as well.
Repeat the question again.
So let's say O is a point in space and
Hmm.
A is some planet and B is
Okay.
some satellite rotating around that planet.
All right.
So that planet will be rotating around the sun,
Yeah.
and if I need to locate the position of that satellite on that planet,
Okay.
I will need.
I understand your problem. So what you first need to do, you first need to analyze this planet with respect to sun, right? A. For that, you use the same kind of diagram. Your R naught may be 0 there. Okay. Only small r would be there. So just consider the planet which is rotating around the sun. Just consider that is this B first. Okay. When we solve a complicated problem, what we do? We split the problem into simple problems. That is the only way. Okay. You cannot take the whole problem and solve it. We have to break it into small problems. So first you solve the problem of a planet. Okay. So this is the planet. Okay. In that case, your R naught may be 0. Only you have this vector, which is nothing but this vector. Solve the problem, velocity and acceleration position of the planet. Once you have the velocity, acceleration, and position of the planet, with respect to that, then you solve it. It's a representation, okay? And then when you apply it, how to apply it, that also you need to know. So when you calculate, suppose you want to calculate, you, as you said, a planet is rotating around the sun, and you want to calculate its velocity first. So you have this, we arrive to this is the velocity, and there you need to know what is va. For your case, vo would be there, because you are calculating velocity with respect to sun, which is, we consider, is fixed. So then its velocity is 0. You have only this term. Once you have calculated this and get the planet's velocity, it's fine. Now you can go for a satellite. Then then for a satellite, what is the velocity of a satellite? Satellite's velocity is the velocity of the planet plus velocity of the satellite with respect to the planet. Do you understand?
Yes, sir.
Is this the question?
Yes, sir. So we'll use this equation two times
Yeah.
to look.
Yes, yes. So this is very important thing. You must understand that a complicated problem you cannot solve just applying a formula. First, you need to learn how to split that problem into simpler problems. Okay. And then you solve those so small, simpler problems. It is also an art, how to split a complicated problem into simpler problems. That comes through practice. When you deal with such kind of systems, you apply your common sense and split the problems. And the common sense is not very common. Common sense based on the principles of mechanics. Okay, shall I move?
Yes, sir.
So let us first understand these terms. Okay, and yesterday we have the last discussion. We finished the discussion here. Let us begin here. This is our lecture number. What is the lecture number? 12. And
12.
yeah, today is 9. So first we will discuss this acceleration of point B. Acceleration of B, which is given by this formula 11.7, and that is what? Acceleration of B is equals to acceleration of A plus acceleration of B with respect to A. Okay, and then what is this acceleration of B with respect to A? The four other terms in this formula. What are those four other terms? Alpha cross R plus omega cross R plus, so this, I don't know how to remove. Okay, and the third term is twice omega v relative plus a relative. One by one we will understand what are these quantities. And okay, so let me write here, this is the acceleration of A, and this is the acceleration of B with respect to A. Okay, let us understand what is this term. Alpha cross R. First, tell me what is the direction of this alpha cross R. R is a vector like this, and alpha, if alpha is positive, alpha direction, what is the direction of alpha? Perpendicular to the board, right?
Yes,
This
sir.
is
Yes,
the
sir.
this is the direction of alpha. Now tell me what is the direction of alpha cross R?
Upward. Plus y.
Hmm?
Upward direction.
Upward.
Upward direction. So this must be like this. Okay. This quantity is alpha cross R. You remember from your school that there is a tangential component of acceleration which is alpha R, right?
Yes, sir.
This is the tangential component which is alpha R. But that is something where already you know that this is the tangential component, so the value would be alpha R. But from here you don't need to remember. You can see, if you just write down the vectors properly, then it will come automatically, it will come. Okay, now tell me what is this quantity. So can I write this is the tangential component, tangential component of acceleration alpha cross R. Let's go to the next quantity, omega cross R. Let us first find out what is the direction of this acceleration, component of acceleration. So this is the vector R, and this vector is rotating with angular velocity omega. Now tell me first, omega cross R, what is this direction? Omega cross R,
Upward.
omega
Upward
cross
direction.
R is this direction. This is omega cross R. This is not a acceleration. Okay. When you cross that thing with, again, cross multiply with omega, which direction you get?
Opposite to the R
Minus
direction.
R curve.
Minus RK direction. All of you are getting it, whatever discussions we are making now. The direction
Yes.
of, okay, direction of this is this. Okay. So this component is omega cross R, and you know, very simple, this is omega square R, right? The magnitude is omega square R, है ना? That is a component
Yes,
of
sir.
acceleration, and that component of acceleration is along the
Center.
along along the length of the vector or link, है ना? I'm writing here along the vector. Okay, for your case, suppose for a link you want to find out what is the acceleration. So there, right now we have examined the two components of acceleration. This is one component of acceleration, and this is another component of acceleration. So one component of acceleration is tangential component, another component of acceleration is along the length. Now, do you remember from your graphical method of finding out velocity and acceleration? There are two components. One is tangential, another is along the length. Do you remember?
Yes.
So how they are tangential and how they are along the length? From this you can understand why they are like that. Now, so after discussing this, let us now discuss this component. What is this component? Twice omega cross B relative. Okay. First, let us understand what is B relative. Okay. So to understand that, we must first go to the definition of B relative. Okay. What is the definition of B relative? Where, yeah, this is the definition of B relative. ddt, derivative of the magnitude in the direction of r. I'm writing here the same thing. Derivative of the magnitude and in the direction of r. Can somebody give some example? What is this v relative? Suppose you take one vector like this, and that vector is changing its magnitude with time. Okay, if the vector changing its magnitude with time, this change divided by time gives you this quantity, right?
Yes, sir.
Right.
Yes, sir.
So that is the change in the length, and in which direction? It is in the direction of r. So that is a velocity, because distance divided by time is nothing but velocity. That is called v relative. Relative means relative with respect to this only. So with respect to this, there is some velocity. So that is called v relative. For example, as we were discussing yesterday, suppose there is a link, and that link is having another prismatic join with it, where this this is like a piston, and you have some hydraulic system in it. uh, when the fluid increases in it, so this part will go out, and this can go in also when the fluid decreases. Okay, that's what the hydraulic control do, right? So now if you just consider this whole thing is one link, then you can see that the link length is changing, right? Hello.
Yes,
Yes, sir.
sir.
So that means if you consider this is a hinge point, this point is a hinge point, the other end has a relative velocity with respect to this point, right? Because of its change in length, that is why there is a relative velocity. Okay, that relative velocity is this one. But finally, the relative velocity, if I write any vector, can be written as its magnitude, b relative, its magnitude, and its direction. Okay, any vector can be written its magnitude and its direction. Okay, now if I write down this v relative, suppose this v relative is this one. This is v relative magnitude, and this is the direction. All right. So if the direction is this unit vector r, that means this vector is also rotating with angular velocity omega, because this unit vector r, because the r vector is a rotating vector, so that means this vector is also rotating. And as we have considered here, the r vector is rotating with angular velocity omega. That means this is rotating with angular velocity omega. Not required, just you see here this quantity omega cross v relative. What is the direction?
Upward direction.
Upward direction. So actually it is in this direction, right? Then we call it, the component is 2 omega cross v relative. So we have another tangential component. Have you solved this kind of problem in your graphical method?
No, sir.
You may have solved, you don't remember. So this component of acceleration is called Coriolis. Spelling ठीक है? Coriolis component of acceleration. Do you know about this component of acceleration? जानते हो कि नहीं? Coriolis component of acceleration. This is called Coriolis component of acceleration. And what is the direction of Coriolis component of acceleration? It is again tangential to the direction of r. So you have two tangential component. One is this alpha cross r and the Coriolis component of acceleration, which is 2 omega cross v relative. Okay, 2 omega cross v relative. This is called Coriolis component of acceleration. Okay. Now, if there is no relative velocity, okay, then the Coriolis component of acceleration is 0. We will take another example to understand this Coriolis component of acceleration. Okay, the next term is the A relative term. Okay, A relative. What is the direction of A relative? If we write down the definition, this is d d2 of magnitude of r, and then it is in the r direction. Okay, so as we said that there is a velocity, there is this length, rate of change of length with respect to time. Okay, now if you find out what is the rate of change of this relative velocity with respect to time, that gives you the relative acceleration. Agreed?
Yes, sir.
That gives you the relative acceleration. Now, what is this? What is the direction of this relative acceleration?
Along R.
Along R. Along R. Okay. So now you see the four components of acceleration. Component number one, it is tangential, alpha cross R. Component number two, it is along R, omega square R. It is along R. This is the component, again tangential. This is called Coriolis component of acceleration. And this is a component, this is called relative acceleration, which is along R. So there are four components, two of them, this one and this one, are along R. Two of them, this one and this one, are tangential. Okay. And the first term, A, this represents the acceleration of point A. If you consider a link like this, and suppose the link is the coupler A and B, then to find out what is the acceleration of point B, you must, so suppose we want to find out what is the acceleration of point B. So we must first find out what is the acceleration of point A, and then we have to find out what is the acceleration of point B with respect to A. And what is this acceleration of point B with respect to A? It has how many components? Four components. What are those four components? Alpha. What is the angular acceleration here? Alpha. We don't know, or we know. What is the angular velocity of this coupler? So if this position vector from this point to this point is r, then the first component is this one, second component is this one, third component is this one, and fourth component is relative. Now see, if this length of the coupler is not changing, what will happen to this component? Suppose the length of the coupler is not changing. B point's distance from A is not changing. What is
Zero.
relative velocity?
Zero.
Zero,
So
sir.
in that case, the relative
Zero.
velocity is 0. What about the relative acceleration?
Zero.
Zero.
This is 0. Okay. Let me give you a small problem example. Suppose there is a turntable, a table which is rotating. This is a table, and this table is having a slot diametrically. There is a slot, and in that slot, the mass, very small mass, is moving. I hope this is visible, right? And it is moving such a way. Suppose this is the center. So the distance of this mass is given by r. This distance is, let's say, r. This distance is r, and that r is equals to, for this at this instant, the r is 6 inch, and the velocity r dot, rate of change of this distance with respect to time is 5 inch per second. Okay, and there is some acceleration also. R double dot is equals to 81 inch per second square. Okay, these are the data given. We need to determine absolute velocity and acceleration. This point A, okay, determine velocity. So you must write absolute velocity and acceleration of A at this instant. What you will do to find out what is the velocity of A? Understand the problem. There are few other data which I have not given. Let me give you that. This table is rotating in this direction. Okay, and that is omega equals to 4 radian per second. It has some angular acceleration, and that is in this direction, or you can say it has angular acceleration omega dot, which is minus 10 radian per second square. Okay, either you can draw in this direction, then it is 10 radian per second. I have drawn in the positive direction, and I am writing it that this is minus 10 radian per second. Okay, so there is a table, and one particle there is a table which is consisting of a slot diametrically. On that slot, there is a mass. This small mass is passing through. Okay. We need to determine what is at this instant, what is the velocity of this point, or velocity of the mass and acceleration of the mass. Okay.
Sir, the velocity along slot direction is given 5 inches per second.
Yep. First, you tell me what should I write in terms of formula. What should I write? VA equals to what? The formulas we have, velocity is velocity of a point and plus velocity of another point with respect to this point. Can we write like the same thing here? Suppose I call this point O, the center point, with respect to which the whole turntable is rotating. Can I write like this? It is velocity of point O plus velocity of A with respect to O. Okay?
Yes, sir.
We can
Yes,
write
sir.
like this. So you just consider this. This is vector R and here is point O. So what is R0 for this case? R0 for this case?
0.
It is 0. It's a 0 vector. Okay. That means this V0 is 0.
0.
VO is 0. Another way to understand VO is 0 is a fixed point. This is a fixed point. What should be the velocity? Velocity is 0. And mathematically understand, if R0 is 0, then this is 0. Okay, only thing we have is this VAO. Okay. All right. Now, what are the components of VAO?
Omega cross R plus D
Omega
R
cross
into
R
R
plus,
D
R
R by
dot.
dt.
this is V relative, right? Because you see here, the definition of V relative is this one. Okay, that's what we got here also. This is nothing but V relative, right?
Yes,
This
sir.
is omega cross R plus V relative. Okay, so I am writing this. Now let me again find out what is V relative. In this case, what is V relative? Can you tell me what is V relative?
5 inches per
R
second.
dot.
A dot.
It is R dot, which is 5 inch per second. This is V relative. So let us write down here. Omega is, okay.
4.
Before you do anything, let us define unit vectors. Along this direction, let's say the unit vector is I, and along this direction, the unit vector is J. Okay. So, and perpendicular to that unit vector is K. So, what is omega then?
4K.
Omega 4.
4K.
4K.
Let us write down it here. 4K cross, what is R?
6I.
6i.
6I plus, what is V relative?
5i.
Which
5I.
we must write here like this. Then only it's a vector. So this is 5I. Okay. Obviously, the inch per second is the unit. Tell me what is this value finally?
24 J plus
J
5i.
cap.
inch per second. So this is the velocity at this instant. Now you can see that as it is changing this distance r, the velocity will also change, right? If r changes, the velocity will also change. So this velocity is true for this instant only. As it changes its position, the velocity will also change because you see from this term it is changing, right? Now let us find out when we say the absolute velocity, actually we have to find out what is the, when we say absolute velocity. So this is VA only, and when we say absolute velocity, actually we want to find out the magnitude of this velocity. How to find out magnitude?
Root over 24 square plus 5 square.
What is this quantity? It is there in my note. I am writing for it from it. And you can verify, okay? Now, let us find out what is the acceleration. Okay, so acceleration of point A. What should I write? This is equals to,
Acceleration of O plus acceleration of A with respect to O.
right? So, and what is acceleration of point O?
0.
0.
0.
Okay, so we just write it. This is equals to 0. Only term we have acceleration of A with respect to O. So it has generally 4 terms. Let us write all the 4 terms. What are the four terms? Can somebody tell me? What is the first term?
Alpha cross
Right.
r.
Alpha cross R.
Plus
Omega into omega cross
Cross
r.
omega cross.
Omega into omega cross R.
plus
2 omega cross V relative.
Relative.
plus.
A
A
relative.
relative.
So we will calculate, but let us do it one by one. Okay. So what is alpha cross R?
Minus 10 J.
What is alpha cross R? Alpha is minus 10. Bolo?
K.
K direction.
Yes, it is K. It is not J. It is K. Okay. Minus 10K multiplied with
6i.
6i. Do the calculation. I'm going to next. What is omega cross R? Already we got this is 24J is the omega cross R, right? So this is 4K. Let me write it. 4K into 6i. Okay. And the next one, twice omega cross B relative. This is 2 into 4K multiplied with, what is B relative? 5i. ठीक है?
Yes, sir.
What is A relative? From the
81
data,
A double dot.
I direction.
81.
Sorry, R.
Follow 81.
I direction.
I can.
I direction. Now calculate all this one by one.
Minus
Ki
60
is minus 60
J.
J.
Ti, J.
And this is
minus 94i,
90,
96i,
minus 96 I,
96i. This one,
plus 40J,
40J.
40J.
this one. लिखने का जरूरत नहीं. ठीक है. Now you add them all.
minus 59 minus 20J,
Minus
15I minus 20J.
So finally, what is the absolute acceleration of point A?
Root 15 square plus 20 square, root 20 square.
25.
25
This is
inches.
equals to 25 inch per second square. Now, suppose in this problem, suppose this quantity is equals to 0. There is no acceleration. The particle is moving only with constant velocity. With respect to this slot, the particle is moving in constant velocity. Okay, this component is 0 and r is 0. Means the particle is moving and we want to find out the acceleration when the particle is just passing through the center. What should be the acceleration? We say that this r double dot is equals to 0, r equals to 0, but r dot is 5 inch per second. Okay. Now tell me what is the acceleration of point A.
0 omega v relative
0.
2
0
omega v
कैसे हो
relative.
जाएगा?
omega 2 omega
5.
cross v relative.
This term would not be 0, right?
Yes, sir.
This term is 0 because r is 0. This term is 0 because r is 0. This term is also 0 because r double dot is 0. But this term is not 0. Still it has some acceleration. And what is that acceleration? This is the Coriolis component of acceleration. Can you tell me what is the direction of this acceleration?
Along
Radial.
Plus
Eh?
j
Tangential.
I.
It is
tangent plus j.
tangential, right? Whatever we got from here, this 40J. That means only this way you can have examples through which you can get when only this component of acceleration is existing. When only this component of acceleration can exist. This component of acceleration can exist. Right now we have shown that this particular case, this particular example, you have only this component of acceleration. We can find out other ways also. Okay, so this way in practice the acceleration has these 4 components plus the first point's acceleration. Okay, this particular case we have taken this first point is a fixed point, a point is a fixed point. That is why this acceleration of point A, or in this case point O, is equals to 0. Okay, is this clear? Shall we move to next example?
Yes, sir.
Okay, so let us take the next example. I don't know whether we can complete it today or not, but let us take it. This is an example. And in this example, we take a figure like this, a 4-bar mechanism we are taking. We will solve this 4-bar mechanism problem using
सर
बोलो.
सर अगर R 0 है तो V रिलेटेड dy dt होगा तो वो तो कांस्टेंट तो 0 हो जाएगा.
कैसे? R is 0, but rate of change of R is not 0. Do you get it? Not possible. R is 0, but rate of change of R is not 0. Possible or not possible?
Yes, sir, possible.
Then your question is solved. Okay, so we draw a 4-bar mechanism which at a particular instant looks like this. तुम लोग ड्रॉ तो कर रहे हो ना अपना कॉपी में, just the coupler. I hope you guys are taking class note. So this, in this case, this is the crank, okay? This is the crank, and the crank is rotating with angular velocity. Let us call it omega CB. They are writing omega CB because this point, we call it C, this point is B, this is A, and this point is, let's say, O. Okay, the distances are, this distance is 100, same unit, 100, and then from this line to this line, this distance is 50. Okay, this distance is 50. Am I audible?
Yes, sir.
Hello?
Yes, sir.
I'm sorry.
sir.
Yes, sir.
Suddenly the system restarted. I could not figure it out. So this was the problem. Is it visible to you, this whiteboard?
Yes, sir.
Yes, sir.
The distance between these 2 points is, this is 250 and this length is 75. Obviously, we have not drawn it with proper proportion. In this case, this OA is vertical and CB is horizontal. We need to determine the angular velocity of OA and AB. You know how to graphically solve it, right? Hello. How to find out the angular velocities of OA and AB? कैसे करते हो?
ग्राफिकल मेथड में सर
Yes.
सर सबसे
सर
पहले
पहले
जो
6
लेंथ
पॉइंट्स
का
को एक सिंगल पॉइंट
का
एज्यूम कर
गिवन है
देंगे.
यस सर
So suppose we now first we solve it analytically, then we'll go for the graphical method, and you will see that how this analytical components and graphical components, their relation, right? So the limitation of graphical method for this cases, what is the limitation? Limitation is you can find out, suppose you have this configuration is given, so you can find out the velocities, required velocities for this configuration only. When the configuration changes, suppose this suppose then at next instant the coupler come to this position or this position, whatever may be, then the velocities will change. Yes or no?
यस सर
So that
Yes, sir.
cannot be solved. That cannot be solved using your graphical method, because every time for every configuration you have to draw those diagrams. But for analytical method, it is not like that. So any vector equation, any vector equation can be written as two algebraic equation. Is it not? See here, you can see that there are two components. Actually, ij, everything will come in terms of I and j. So you can write down the equations along I direction and along j direction. Any equation here. So every vector equation is here. Actually, they are two equation. If you have a three-dimensional problem, any vector equation you can write it in terms of three algebraic equation. And then these algebraic equations are very easy to handle in your computer. So you can write down codes to find out the velocity and acceleration at each step. Also, you can then draw what is happening to velocity and accelerations. You can plot it with respect to time. Okay, and you can see where the acceleration is maximum, velocity is maximum, and based on that, you can then decide dynamics, because the dynamics will depend on your acceleration and velocities, right? Based on that, what should be the torque required to run the mechanism, that can be determined from those values. Okay, so what is the maximum torque required, that also you can determine, which you cannot do using your graphical method. Yes, you can do, then uh, you have to draw the same diagram for all the crank angles, and then you'll get it. Okay, 360 diagrams you will draw, and then you'll get where the acceleration is maximum for which configuration. I don't know today can we complete this or not. I have another class from 11. Okay, let me do it tomorrow. Tomorrow we will solve this problem. We want to solve here what is the angular velocity and acceleration of these two, and then we will solve what is the angular velocity, angular acceleration. Sorry, what am I talking? First, we will find out angular velocities of these two links, and then we will find out angular accelerations of these two links. Okay. This is a mechanism where you don't have relative velocities, right? Can you see any relative velocity here? All the lengths are fixed. Okay, the distance between A and B is fixed. Length between B and C is fixed. The distance between O and A is fixed. So there will be no relative velocity or relative acceleration. But when you consider a mechanism like those quick return mechanisms, in those cases, without quick return mechanism, in those cases you will see that the velocities you will come across with relative velocities, then your Coriolis components will come in that case. Okay, let us discuss it tomorrow. Not tomorrow, Monday, right? Today's lab will be taken by the TS. Fine. If you have any more question, you can ask me, or I will stop this class. Hello? Do you have any question?
No, sir.
Fine. Thank you.
Thank you, sir.